Hey guys, this is Module 1, Lesson 1, classifying variables. um, so, in statistics, there's two types of data that we want to collect. There's categorical data, also known as qualitative data, and then there's quantitative data. So, categorical data is data that we can't associate a numerical value to, um, or a meaningful numerical value to, I should say. Um, things like color or brand or gender or things of that nature. We can't put a particular numerical value on them. So, like color, brand, gender, location. Okay. Quantitative would be things that do have a numerical value. So, um, height, basically any sort of dimensions. Okay, things that you can measure with a ruler. Weight. Time. Uh, Cost. Okay, anything that we could associate an increasing or decreasing numerical value to. Now we have to be careful with quantitative because a lot of people just say quantitative, that just means numbers. And we take the example of an area code or a zip code. A zip code is actually a categorical or qualitative value because even though they're numbers, they don't have any sort of increasing or decreasing value associated to them. You can think of a zip code as a sort of it's a numerical name, right? So it's a set of numbers, but all it is it's just a representation of a certain geographical area. And higher or lower zip code numbers don't associate with anything. Well, let's take a look at some two-way tables. When we're looking at two-way tables, there's two types of numbers that we're looking at. There's marginal distribution and there's conditional distribution. And the way to remember that marginal distribution has to do with what's in the margins. They're the totals in the margins. So they're one dimensional. Spell. So for example, if we look at one marginal distribution would be what's going on down here. So this would be a marginal distribution. So this would be, for example, a breakdown of how many people in our survey had less than 3 members in their household and how many had more than 3 members in their house. I will say offhand that this is a category and it's kind of barely a category. We are almost in the realm of a numerical, a quantitative measure. In fact, if we were to, ask instead of do you have less than 3 or more than 3, and we just asked how many members were in the household, we could actually come up with a quantitative measure. So I'm going to allow this as a categorical categorical classification, but just barely. All right. So that's a marginal distribution. That kind of tells us, looking at this breakdown, 370 and 360. We almost got half and half here of our within our survey. We could also look at another marginal distribution over here. of the total people, this tells us how many voted strongly against or against, and we're neither for nor against or for or strongly for. Okay, so it's the breakdown of the total answers. And that's a marginal distribution. A conditional distribution would be something that's in this column here. Okay. So now we have 2 dimensions. Okay. Not only are we looking at within a greater than 3 members in a household, but within that we are looking at how did that break down. So this is a more specific breakdown, a more specific distribution. So that's why we call it a conditional. And both these things can give us information. So association. Association means what is there a relationship between our categories? Okay. Some people something you want to avoid is don't think of it as the same term as a correlation. Correlation is something we'll talk about later. That only happens when we are talking about 2 quantitative data. So association is just looking at, for example, is there a relationship between the number of members in our household versus how likely we're going to be looking, or how we're going to feel about paying for a new public swimming pool. Okay. Well, let's say we want to figure that out. So what we want to do is we want to look at a conditional, compare conditional distributions. Well, what do we want to look at? So we want to look at these numbers. So let's say we're looking at who's strong and what percentage is strongly against. So against and strongly against. So we want to look at these raw numbers here. But raw numbers are kind of tough to deal with. We really want to get things into percentages. So we want to take this 43 and we want to divide it by a total. But which total do we want to look at? Do we want the total on the right, or do we want the total at the bottom? And the answer is we want the total at the bottom. We want to know what percentage of total household numbers greater than 3 are either strongly against or against. So we want to put these over 360 here. Okay. I mean, we could divide these by 134 and 131, but all that's telling me is that of the total percent, what number were members that had greater than 3 members in their household. And that might work in this case, simply the fact that our numbers are fairly similar between the two. But if we, for example, happen to test a lot more members that had more than 3 members in our household, for example, we had like 200 more, it would offset the totals here, and we really wouldn't get a good idea. We would expect that there would be more people in the total that were had greater than 3 members in our household and were against the public school, simply by the fact that we tested more of them. And we also want to take a look here. We want to divide these by 370 to get a percentage. So we'll see if that way, by comparing the same conditional distributions, we will get an idea of what, if there's an association. So about 25%. And this is about 27%. of members who did not have members were going to be strongly against. Versus if we do we get about 12%. And about 9%. Let's put these together. So 25, so this is roughly about, if you had less than 3 members in your household, about a little more than 50%, so about 52% of those people are going to be against getting in the swimming pool. But if we add these together, we're going to see that only about 21% of people who had 3 members in their household were against the swimming pool. So it kind of tells you that as we get more and more household or members in our household, we're less and less against the idea of getting a pool, and that might make sense. Maybe as we get more members in our household, we got more people who might be interested in swimming, got more kids, maybe we're more likely to use a pool. So that's how we do a two-way survey, or looking at association. Okay. Let's look at another case here. So we have Titanic survival data, okay? And I'm wondering, is there an association between class and survival? Okay. So again, we're going to be looking at conditional data here. So let's look at comparing our third class passengers with our first class passengers, okay? So again, we have 528 third class passengers did not survive, and we had 123 first class passengers. Now again, it's very tough to just look at raw numbers here because we know at the start we had a lot more third class passengers. Okay? So we're going to expect that there's probably going to be more than them just in general. But we want to know, did having a first class ticket give you a better chance of survival? So we want to compare this to a total. Which total do we want to use? Do we want to compare it to the 817? This is the total number of people who didn't survive. Or do I want to look at this total, which is the total number of third class passengers? Well, the answer is I want to compare it to these numbers. Okay, the original set. I want to know what percentage of my first class passengers didn't survive, and I want to know what percentage of my third class passengers didn't survive. I don't really want to look at the breakdown. If I compared them to that 817, that would simply tell me what percentage of my passengers that didn't survive were of the first class and third class. And it gives a little bit of information, but not enough to tell us whether there's an association, simply because, as I said before, we had more third class passengers to start with. So let's do that. Let's take a look at those percentages. So 123 divided by 324. Okay, so about 40% of first class passengers did not make it. $528 divided by 709, and we got 74% of our third class passengers didn't survive. So that's kind of telling us a clear answer that if you were a first class passenger, you had a much better shot at surviving than if you were a third class passenger. Okay. So we have two examples here. you have to really look. It's not always. You have to look at which margin you're going to divide by. Is going to tell you more information. So in this case, we were looking at marginal information happened to be the totals of the original numbers were on the bottom. In this case, they're off to the side, so it's not always one or the other. You have to really pay attention to which totals you're looking at. Just to give us even more evidence, let's take a look at our survival passengers. Just make sure that everything makes sense. Let's compare our survival rates. So 201 divided by 324. So we got approximately 62. Okay, I did do that wrong. I was typing the wrong number, so that these two needed to add up to 100. Something didn't look right. Sorry, that was 38% survival rate. Okay, so these should add up to 100 or to 1 or 100%. So no. And yeah, that should be 26%. So always check your numbers, okay? So yeah, we can see it over here. We could have done this with the survivors. So 62% of first class passengers survived, and only a quarter, or a little more than a quarter, of third class passengers survived. So, and if you watch the Titanic movie, that makes perfect sense, because Rose could have definitely fit Jack onto that table, but she's first class. She can't have that third class passenger sitting there. She wants that thing all to herself, so she lets poor Jack freeze to death and drown, and she saves herself. So because she's first class, that's my opinion anyway. That's our lesson, and I'll see you next time.